Good afternoon, everybody, and welcome to the final presentation for the Northeastern University's Advanced Software Development course, which is part of the Master's program here. And this also serves as the launch of the initial version of the ClimateTree website. So Advanced Software Development is designed as a project course where a substantial team of students, this year about 20, from our locations in Boston, Seattle, and San Jose, collaborate to build and launch a software product, all in a single semester. We work with public good non-profit participants and have been fortunate to connect with the Seattle-based Democracy Lab, which acts as an incubator for such efforts. Through the Democracy Lab, we have met our collaborators on this project, Greg and Abby, who are the inspiration behind the site we built and are on this call. I know it seems a long time ago, but in the before virus times, global climate change was at the forefront of the problems for governments and society to address. You might even remember the climate strikes led by the youth of the world last year. ClimateTree is inspired by these and other events. The vision is that students and concerned community members could use ClimateTree as a catalyst to partner with locally elected officials and other community leaders to create policies needed to meet greenhouse gas reductions. Anyway, I'm going to hand over to the class now to show a demonstration of ClimateTree and then briefly describe the underlying design and technology used. The site is hosted on Microsoft's Azure cloud platform, and I'd like to thank the education folks at Microsoft for giving us the funding for this initial deployment. I'd also like to congratulate the class. With the geographical and time displacements, Advanced Software Development is intended to be a challenging elective in a pandemic, and we're all in unknown territory. Over to you, Evan.
All right, thanks, Ian. Hello, everybody. My name is Evan Douglas. I was one of the developers on this project, and I'm going to go ahead and show you a quick demo of the site that we have. All right, so this is the landing page of ClimateTree, the home page. We designed this so that it highlights the three main things that the site is for. And I'll go into each of these in more detail as we go. But the first is something called stories. And for us, this is what we call a climate change solution story. If I scroll down here, you'll see some of the top stories. So we have trending stories here, basically. And these are examples of what a story are or is. So essentially, it's a hyperlink preview. These all link out to the web. And if you click on them, for example, we can go and watch this video. I won't actually watch it, but we could watch a video of this farm here, or same thing for each of these. If you click on it, it'll take you to the story and you can read through it as you wish. The next thing that we have is a map function. And the map basically allows you to look for places that are similar to yours around the world and search for stories in those places. The idea there being basically that if there's a place similar to yours, you are probably more likely to be able to do the thing that they are doing to help combat climate change, rather than, for example, a much bigger city or a nation or something like that. So you can get to a more community level with the map. And then the last thing is research functionality, and I'll come back to this later in the presentation. But essentially, it allows you to share your research, your stories that you find in the world about your place or other places, and basically create a community around climate change solution stories. Okay, so that's everything for the landing page. I'm going to head over to the map now. And a few things to point out at first. We have a search bar up here where you can search for your place. There's an advanced search, there's a search tips button, and this could be important if you come back later and don't quite remember how this site works. You can click on this to read through here. I won't actually read through it because there's quite a bit of text, but it'll give you a good idea of how the search works. In addition, if you don't particularly like this dark background, you can change that just as an option. You can see a National Geographic style background. I happen to like the dark one, and I think it fits well with the rest of the styling of the site. And then come back up to advanced search here. So The default search has a population range. So whatever you type in here, it will grab you places around the world that are within 90 to 150% population range. As you see, you can adjust this for a more advanced search. You can also include carbon, what we call carbon percentage. And there's also something called state, nation, county, and urban extent. So back to advanced search here. By default, what our map does when you search for a place is it will find places in the world that are similar to that. Again, by default, it'll find places within a population range of 90 to 150. As you can see, you can also include carbon output. I'll show you what that looks like in a moment. You can change the values of these. And we also have 4 different types of places in our database. We have a state, nation, county, and what we call urban extent. So a quick way to think of urban extent is it's sort of like a city, but it's a little different. So to give you a quick idea, if I go to the home page here, in the background here, you can see these pictures, this picture of Earth at night. So all these little light blobs, you can consider those as an urban extent. So like one of these big ones, for example, I'm sure this isn't Seattle where I'm talking from right now, but you might imagine that this big blob encompasses a lot of Puget Sound, Seattle area, and not just Seattle City, for example. And so going back, since ClimateTree was initially started in Thurston County, Washington, I'm going to go ahead and search for places that are similar to Thurston. Thurston, if you're not familiar, it contains Olympia, Washington, which is the capital of Washington. Oops, I spelled it wrong. All right, so we can see that there are 2 places in our database that are called Thurston. We want the Washington one. All right, so the first thing you'll see here, when you search for a place, it will highlight the place you searched for. You'll see a number of other dots around the globe, and you'll see some statistics up in the corner here. The statistics are just some basic ones with population, population density, carbon, and carbon per capita. And as you go around, you can start exploring some of these places too. So if I zoom out, this is what this will look like if you see all these places. And you can see as you zoom in, some of these clusters will change dynamically as you go. But let's say I don't want to find all of the places just within this population range. I want to narrow it down a little bit. So I'm going to narrow it down to between 90 and 110% population of Thurston. I'm going to include carbon, and I only want to see places that have at least half as much carbon output as Thurston County, so 0 to 50%. To narrow it down even further, I'm just going to go with counties. You know, this might be helpful in certain situations where you're trying to get your local government to do something, and perhaps it's best to show them solutions from other places that have the same general style of local government. So hit apply. Again, we're going to zoom back in, but you'll see a few things. Some of these dots down here are gone. If I zoom back out, might be hard to tell, but there are fewer of these dots here. And so from this point, we can start exploring around the globe. I'm going to start here, Rockingham County. So when you click on one of these places, you'll see that a pop-up pops up with the name of the place. There's a story, view stories button. You also see these over here. We'll get into that in a bit. But what I want you to notice with this one is that we have this extra card down here with comparative statistics to your target place. So we can see that this county in particular has about the same population, slightly higher, and population density, but it is outputting quite a bit less carbon. So again, the idea of this is that we find similar places to ours, but they're doing something right with climate change solutions. So we want to see things that they're doing. So perhaps we can make our place do those things as well. Moving around the globe, there's a place called Afar Zone 4 County in Ethiopia. And here you'll see some extra content down here. These are the stories we showed you before. So just like before, you can go and click on these. It'll open in a new tab, and you can explore all the ones in the list here. It'll show everything that is related to that place. And we can explore a little more. So Finland has some interesting stories. And I'm going to settle on Grass County, Austria. So this is an interesting place because it's about the same population, but quite a bit higher population density and quite a lot lower carbon output kilograms per year. As I scroll through, we can see that there's quite a few stories related to this place, and they look pretty interesting. So I'm going to go ahead and learn more about it and click on View Stories. All right, so this will take us to our primary stories page. This will look somewhat similar in terms of these little cards that have the story information in them, but you will notice some differences here. So on this page, we kind of have a social aspect to it. So you can like stories, you can remove your like if you want. If the content is something that's you feel not appropriate for some reason, you can flag a story. And you can also enter comments. So perhaps I like this one a lot. Go ahead, enter comments, and that's what that'll look like as you scroll down. You'll see other people's comments there as well. One thing to note, if you happen to be following along, is that you might not see this whole section right here if you have not registered with the site or logged in. We decided to do that because we just wanted to prevent essentially trolling. So there's a little bit more responsibility if you're posting and your name comes up here. Moving on, there's, as a user, you can delete your own comment. So I can delete my comment. If I had posted this story, I could delete that too. And in the vein of helping to, make content good, we also have a moderator role, and moderators can delete all comments, they can delete stories, and they can edit stories as well. So I happen to be logged in as moderator right here. So if I click on the little ellipsis, this is what you'll see. You can edit, delete, or just cancel out of that. But I won't go into that too much right now. So as we scroll down, we see there's a lot of stories for this place. And I kind of want to filter out, just out of curiosity, I want to see something else. So I can use these filters over here to do that. And I'll explain a little bit more about these. But first of all, I'll show you how they work. So if you just click on something like mitigation, then you'll see another part pop up, climate sector. So I can click something like buildings and cities, and then you'll see another one pop up that is solution. Now you don't actually have to pick all of these. So just to demonstrate that, you can filter, and then you'll see only the things that are related to climate change mitigation related to buildings and cities. So there are a few here, and we've narrowed it down to 4 from all of them. Again, we could do something like district heating, and then filter it down even more. So here I can, again, click on these things if you want, go explore this as much as you want, come back. But let's say, like, this story interested me a lot. Let's see, solar, I'm interested in solar, but perhaps not from this place. I just want to see solar from around the world. At that point, I can come up here. I can just type in something like solar. This is just a keyword search. And then we'll see stories from around the world related to solar. As we scroll down, you see Arizona, Yemen, Sudan. So you'll see a lot of different places. And again, you can use the filters as you see fit. If you just want to do mitigation, you could do that, filter it down. Okay, let's see. And from here, I want to show you what you can do to actually add these stories. So these are stories that are already in the database and the website that you can explore. But a big part of this is sharing with the community. So with that, that's what we come to research with. So again, related to those filters, we basically used something called Project Drawdown to classify the filters, essentially. So perhaps Greg and Abby can talk more about what that is later in the presentation, but for now, I'll just show you what it looks like on their website. So if I click on this link, so this is the search solution and then search place, but Project Drawdown has a list of solutions, and this will take us to their table of solutions that we have used. So there's a bunch of them here. You can go down and explore to your heart's content. Let's say I like bicycle infrastructure. I can go ahead and just copy that, bring it over here, and then I happen to be in Seattle, so let's look for Seattle. And I want to search the web. So you can see this brings us over into Google. Now, of course, you don't necessarily need this to search Google, but you can think of it kind of like a framework to help you learn how best to search for it in a sense. So, eventually you could just come over to Google and find things, but we wanted to help users out in case they weren't sure. And I want to go to news, and let's say I click on this site here. So in Seattle, there were a lot of bike share rides last year. It's a .gov site, so it seems pretty reasonable, interesting story. So if I want, I can go ahead and copy that URL, and I can upload it to ClimateTree. So this is the login profile that you'll see as soon as you log in. And again, you see some trending stories, but you also see this, my stories. You can post a story here. If you just pop in the hyperlink there, enter the place just like the map. So this is for Seattle, which is an urban extent. The media type we already saw was news. So, oops, that's not what I wanted, news. And the strategy, sector, and solution used for filtering these stories is actually optional here. I think the media type is too, but you don't necessarily have to know exactly the whole hierarchy of these. Since I just copy and pasted bike infrastructure, I can go down to solution and start typing in bike, and then we have bike infrastructure, and it'll fill these in for you, just so that you're not constantly exploring things. Hopefully it'll go a little faster. So you can post that. And automatically we'll see that story is now in the database. So if we went to the map and looked for Seattle stories, we would find this in the list of stories there. We could search based on the title and we'd find this one pop up. And again, as a regular user, you can go ahead and edit and delete your own story if you want to. The only reason I'm seeing these down here also is because I happen to be a moderator as I'm logged in here. And so that's pretty much the gist of everything. We did have a lot of help comments in here. So if you're not sure how to do something as you're exploring the site, please feel free to click on all the learn more buttons. There should be one for pretty much every page. We have map, so learn more about ClimateTree map, and that'll take you over here. There's stories, the research, how to log in, and then some general information. If you want to learn more about ClimateTree in general, after this presentation too, we have an about page with a bunch of content here. This is our team, so just a quick thank you to everybody. We all worked hard on this semester, and I think that's about it. Thank you very much for your time, and let me turn it over now.
Hey, thanks, Evan.
Absolutely.
So we'll hand over to Kanika, who's going to share some slides, and the team will describe some of the technical infrastructure and how they built this thing. And then at the end of that, we'll go to a Q&A.
Thank you, Professor. Thank you, Evan. The demo looked really good, and I hope you really enjoyed it. I'm Kanika Rana, and I'm representing the entire team as the Scrum Master today. I'm situated in Boston, and let me take you into the roots of the website you just saw by going over the technical overview, followed by the details by the corresponding team representatives. So starting with the technical architecture, we are following a microservices architecture. And we have 4 microservices at present, which are the user service, places service, story service, and geo server, respectively. We'll go into the details shortly. The data in places is populated using the information collected by Greg and provided to us in a spreadsheet, which is why it's a relational database, which is associated with both the places server and the geo server. The initial data for stories is populated by scraping the internet with the search term provided. We are using, as I previously said, we're using a microservice architecture. We're using, and it was really helpful in parallel development. This is also the trending architecture in the industry at the moment. Our website is hosted on ClimateTree.wiki, which is on Azure, which is a cloud platform. So the users interact with the website, and each interaction from the front end comes to the gateway directly to fetch the information from backend data, which are these services. I'll go into the details of the gateway in the next slide. But the main reason for the gateway is to verify the authentication of the source and the user to correct and to route it to the correct service for the interaction. So going on to the question that why are we using gateway? It is because that the microservices architecture, the data for an interaction by user might be spread over multiple services. This makes the client, which is our front end, to access individual services difficult. Also, the second would be maintaining the changes over services. So if there are any changes on individual services, it can have a rippling effect on the changes to be made for front end because they might be accessing it at multiple places. And maintaining that changes again becomes difficult. Also, the security, since it is a web application, it is prone to a lot of hacks. Thus, we use the gateway as the single point entry to the clients. We use Express API gateway mainly because it is a gateway which is specifically built for microservice architecture. It is open source and it is built on Node with a good documentation. So we use three main features of Express Gateway at the moment. The first one being CORS, which is the cross-origin resource sharing. We restrict the access to gateway to only the front end, which means that if any other site tries to access the gateway, it will get no response. We use the proxy pipeline to route calls which are made to the gateway to the correct service endpoint. The last feature that we use is the JWT, which is JSON Web Tokens. We'll get into the details about JWTs when microservices present. So basically the JWTs hold the evidence of validity of users, service endpoint sensitivity. So if there is we nip it in the bud by routing the endpoint only if the token is valid. For example, we saw that only registered users can comment. By registered user, I would say who've already logged in. So if there's a user who has not logged in and it tries to connect, the Express Gateway checks that the user is not verified and does not route it to the corresponding service. I'll take it. So now the four microservices, which are the user service, places, stories, and GeoServer. We'll revisit them in the mentioned order. So I'll let Shweta go ahead and present the user microservice. Thank you.
Thank you, Kanika. Hello, everyone. I'm Shweta Mandogane, and I'm located in Seattle. I'll be representing the users microservice team to explain the technical details of the service. Next slide, please. User microservice is the backbone of entire user authentication and authorization system. Every user who logs into ClimateTree is routed to the user microservice. The microservice registers the user to ClimateTree. By register, we mean that we allow a user to perform specific operations based on their roles. For example, we have three roles as mentioned here: general user, moderator, and admin. So each user has a specific function to perform, as Evan has already discussed in the demo. And for this purposes, we have used the role-based access control system. Moving on to the APIs that the user microservice offers. There are 5 APIs that the user microservice offers: to register and log in a user, then search users, delete users, update user role, and blacklist or unblacklist a user. Of these, general users can only log into the system. whereas moderators can blacklist and unblacklist users, and admins also have some extra rights of deleting the users. Next slide, please. So here is a short journey of the user after the gateway redirects the request to user microservice. So as we already saw, the gateway sends a request containing the name and email to the user's microservice. Here, it is important to note that we do not store any security credentials like password at our end. That is handled by the Facebook and Google OAuth for us. When we receive this request, we check if the user is already registered with us. If yes, then we directly send the access token with the user role and ID to the gateway. Otherwise, we will first register the user into our system and then generate the access token with role and user ID. Next slide, please. So as we already saw that we are using token-based access for authorization and authentication. And for that purpose, we are using the JSON Web Token. JSON Web Token is an industry standard that defines a compact, self-contained way for securely transmitting information between parties as JSON object. ClimateTree uses RSA standard secret key to sign the JWT. And JWT is encrypted, so it is secure for now. And if we decode the JWT of ClimateTree, we will see that there is user role and user ID in it. Next slide, please. Here are a few technical details of how the service is implemented. So we have used Java language and Spring Boot framework. For database part, we have used Postgres. And as per the technical diagram goes, the service layer contains the REST controllers, JWT services, and repositories. The REST controllers are where our endpoints are called, which in turn call the services and perform the database operations. The database layer is our Postgres database. Here is a link to the documentation that is mentioned on the slide for the API calls and everything. Now I would like to hand over to the Places microservice. Thank you.
Thank you, Shweta. Hi, everyone. I'm Cole Clark. I'm located in Boston, and I'll be presenting on behalf of the Places microservice team. So we go to the next slide. So the Places microservice controls the access and processing of all the geolocation data and requests that are coming in for ClimateTree. The service was built on top of a PostgreSQL database, and that's the main portion of our microservice. The database contains about 70,000 records of different places across the world. And as Evan shared before, a place can be anything like a nation, state, county, or urban extent. The Postgres database also has a PostGIS extension, which helps with querying and returning spatial and geolocation data. And the database was created based on reliably sourced data that I'll get into in the next slide. The second part of our microservice is the Java application service. This is a RESTful web service that defines 4 API endpoints. So this is where the request gateway would make requests to, and then the Java application service would go to our database, get the query, and return the results. And this service actually caches requests, which improves performance and reduces the amount of calls to the database. So on the next slide, I'll talk about the Postgres database that we've created. So we've worked with Greg to get a lot of different data from different sources and kind of put all of the data into one cohesive database. So as I mentioned before, the database contains about 70,000 places. And you can see the breakdown of the amount of nations, states, counties, and urban extents on the screen here. And so Greg has worked very hard on getting us a lot of this information. And so I've listed the data sources below. And so just to name a few of them, we've gotten our information from the Global Administrative Areas, the NASA Socioeconomic Data and Applications Center, the Fossil Fuel Data Assimilation System, the Nature Conservancy, and then our base maps are from Esri, which is a tool to help with mapping. So on the next screen, I'll talk about what our microservice actually offers. So as Evan described in the demo, there are a lot of different requests that are happening on ClimateTree's website. Our API handles all of the place requests. So for example, the first API that we have is that you can search for a place by its name, and that will be returned with a list of results from our database. So for example, if you search the name Manchester, there would be a request that goes to our Java server and then queries our database for a list of all the places in our database that match the name Manchester, and that list would be returned to the front end. We also have two similar place APIs. One is the default API that Evan mentioned, and the other one is an advanced filter API. So these APIs actually take in a point of interest. So for example, if we gave the server Seattle as our place of interest, it would return results with a list of places that are similar to Seattle in things like population carbon, per capita carbon, and population density. And the advanced filters that we've created on this API allows you to kind of move the ranges of population carbon, per capita carbon, and population density. Lastly, we have an available API that we have called the nearest place API, where you can give our service a latitude and longitude point, and we will return the closest place physically in terms of Euclidean distance to that latitude and longitude coordinate. And so I've listed, I provided a link to our documentation on Postman of these APIs. And then lastly, on the last slide, I'll go over our technical architecture diagram. So similar to the user service, we have a service layer and a data layer. Our service layer is where our REST controller is. That's where the gateway makes requests. And then our application service gets those requests and calls on our service, which calls on our database repository, which actually queries the database and gets results and returns them back through the REST controller. So now I'll pass it on to the stories team to describe their microservice. Thank you.
Thanks, Khoury. Hello, everyone. I'm Yu. I'm located in San Jose, and I'll briefly introduce what does the story microservice do. Next page, please. Yeah, so our main responsibility is to handle the indexing and searching of successful climate change stories, which demos before. We also handle user interactions with each stories, like a user could like or unlike a story. User could post a comment or delete their comment on the story. User could also flag a story which reports to the administrator or moderator and say, hey, maybe there's some problem with this story. Also, we provide crude APIs for interacting stories in the database, and also a high-level API for filtering and searching searching stories with relevant topic. In next page, I'll briefly talk about our basic architecture. So here, the bottom level is the Express, which is our service layer. Its main responsibility is get the request from gateway and return the result to gateway. The upper is our data layer, and also our database. It could be split into two parts. The right part is MongoDB, a non-relational database. It stores all the stories and story command and other information. The left part is Elasticsearch. It works more like a search engine, stores the index of all stories. And when a request reaches Express, and the Express would identify if the request is a search operation. If it is, go to Elasticsearch, get all the story ID by indexes, then go to MongoDB, get all the stories by ID, then returns to the story to express to get away. If it's a create or update or delete operation, it directly goes to MongoDB and then update indexes on Elasticsearch, then reports successful or failed. This is basically how we handle requests from gateway. On next page, I'll talk about our API design and implementation. We provide a lot of RESTful APIs. The link is above with our API docs. We provide RESTful API for stories. We could find our story, find top story, and delete story, and a lot of other APIs. This is just some example of CRUD functions. We also provide RESTful APIs for commands. Given we don't support update on commands, so we only can create, retrieve, and delete commands. We also provide a RESTful API for retrieving other information in database, like say taxonomy, media type of story, the video, news, the type you see before in the demo, and get link preview, which is the brief introduce of a story and the picture. We could get preview by /story/get preview hyperlink x24 . Also, the below are some get a media type in story and find taxonomy by strategy. So, finally, I want to talk about where is our initial data came from. Yeah. So in order to release a site, we have to have some initial data to populate our database. So we build a web scraper which writes in Python and automatically goes on Google to find stories for us. It tries different combination of places which comes from Play service and drop down solutions. Then search them on Google and saves the top result. Now, each story is tagged with the relevant metadata, the place and the solution, sector, and strategy, allow us for nuanced searching. So for now, we already collect around 70,000 stories, which can be accessible anytime. This is all from story service. I'll hand over to GeoServer.
Hello, the GeoServer microservice is what we're using to display places on the map. Just a disclaimer, the places microservice was what we used originally to meet some of our deliverables early on so that we could build the components to display the places that were in our database. So about a month ago, we switched over to GeoServer for future extensibility, and it's a lot faster response time when we were doing our load testing. So let's go to the next slide. So as I said, servers used to deliver the places that you're searching for on the map page. We're utilizing a protocol called WFS that allows us to embed a SQL query inside of GeoServer. As you can see in that screenshot, there's like a SQL query in there with some parameters, the filter parameters that you saw on the front end at the bottom part of the screen there. And what this does is it hooks up to our PostGIS database, pulls those places, all the information for those places, and returns to the front end so we can display it. Next slide. WFS, Web Feature Service, allows us to request that information via HTTP web protocol. And this is a sample request to our gateway with our layer included in it. We only have one layer. It's called Similar Places. Returns the response comes back in JSON. That's what WFS allows us to do. And we have some parameters in there as well. So the next slide talks about all the parameters that we have. Type A, as you saw, we have state, nation, county, urban extent. Evan touched on that earlier. Those are the 4 types, and then we have population low, population high, carbon low, carbon high. Those are the filters that you saw in the advanced search section. And then we also have the capability to extend this to population density and per capita carbon. We can always add filters for that as well, potentially. But we are displaying that information, as you saw on in the panel, whenever you add a new place to that panel, for comparison's sake. Go to the next slide. If you want, you can go to the next slide. For future, the technologies that we're using is Docker for containerization, what we're using in a lot of our services. We're also using PostGIS, and we have our Docker container up on GitHub in its own repository. Right now, we're limiting the places returned to 200. As you can imagine, if we had thousands of places on there, it would get a little bit overwhelming clicking around that map. So we're limiting it to 200 for performance, slight performance gains, and also visual aesthetics. Future considerations, the schema for the database for our places to change to improve performance. And GeoServer helped us a lot with response time, but the database schema may have to change in the future to improve how fast that query runs if the more users we get. And then more layers, that's why we moved to GeoServer. For the future, we can add layers easily. That's a link below to a site that does climate projections based on different economic outcomes of the future. And it's kind of a cool visual that, an example of what we could do to overlay on our map. So yeah, that's how we're using GeoServer. And I believe DevOps is next.
Hey everyone, Herman here, and tonight I'm in Washington. Tonight I'm gonna represent the DevOps team. I'm gonna talk you through what we are using in terms of technologies, how we are hosting this. You might have heard sometimes Docker and Azure before in the presentation. I'm gonna explain all those now. We have developed this website from scratch, and to maintain all the code we required something where we could do code versioning, where we could go back to previous code versions, etc., etc. So for that we chose Git. The online dashboard for that is GitHub. We have also implemented CI/CD pipeline in our project, and for continuous improvement and integration we are using Travis CI. The whole infrastructure, including containers and VMs, which we have deployed, are on Azure. We are also using SonarQube for code quality checks. The containers are deployed using the Docker technology, and we also did some load performance testing, and that was done by a tool using Locust. Next. So now I'll explain what happens when you push your code into Git and how it gets deployed. So we have a few branches in Git develop and master. We only deploy the code through master. Before that is deployed, there are a few things that happen. One of them is whatever the code is pushed to your branch, it should pass all the SonarQube gates. We have configured different gates for different repositories for different microservices. Then Travis CI builds it creates a build, and then if that build passes, then we push an image to Docker Hub. And once the image is pushed to Docker Hub, Azure listens for any changes, and once Azure finds any changes, it pulls and then deploys it. Once the Azure pulls down the image in the container or if it sees any update in the VM, the changes go live. Our current changes are, our current website is hosted on ClimateTree.wiki, but this is the infrastructure behind it. Next. So as I told you that we have used Locust for load testing and performance testing. So we tried to run some scripts and we tested all our CRUD operations to make sure that there are no latencies and the performance between the API calls is up to par. So we did a lot of testing, and our main matrices which we were using were RPS and FPS. That's requests per second and failures per second. We it also tested like the 90th percentile for the API calls, and we were doing this for all the microservices. While doing that, we were able to improve like performance by like twice as well in some microservices. We have like a whole comprehended report at the given link. Next. So now I just want to end the infrastructure slides by showing what is our final cost. We have deployed 3 app service plans. They are hosting different microservices. We have also placed the front-end code in container. That is why we are terming it as a microservice. And these are the 2 databases that we have hosted: Postgres for places and MongoDB for stories. Postgres instance is like Azure service, and that's a little bit expensive, but it's very scalable. Whereas MongoDB is hosted on a VM right now because the alternative service by Azure Cosmos was not what we expected it to be. And yeah, that's it from our side. Going forward, we are looking for partners who can sponsor this infrastructure for this non-profit website. You can reach out to Greg or Ian regarding that. Thank you.
Thank you so much, Harman. I hope everybody had a good time. And at the end, I would just like to end the presentation. We have worked really hard in this entire semester to get this website rolling for today. And we achieved most of the expectations out of us, but I would specifically want to point out something that we are really proud of. This wasn't expected from us, but we went over the board to get this done. We've realized working in the industry and even while in this class that expansion is something which is inevitable. So there are always going to be changes requested on the website, on the product, or be it anything. As long as the software, there will be changes. So that's why the website is built with expansion in mind. You heard Nick say that GeoServer is built because it is faster to use for maps, and also it is easy to get more filters or get more layers, and it can be expanded to work to our satisfaction. We are using Elasticsearch, which makes our text searches a lot more quicker and efficient than the normal MongoDB searches. And we struggled a lot to get the Elasticsearch working, but it was success at the end. Also, using Elasticsearch gives us more options for search, which would not have been possible with MongoDB alone. We use the microservices architecture, which is again one of the most trending architectures in the industry. And this was not something anybody, when we started the class, neither of us had ever worked in a microservice architecture or had experience in building one. So it was a challenging learning curve for us to understand how it works, and there was a lot of preparation for it as well. We have the user roles, which can be expanded for quality content. So right now, not all the APIs provided by user service are utilized on the front end, but once we do, we can expand the way moderators curate the website, moderators as well as admins. And also we have our APIs version. That's all. I hope you enjoyed. Thank you so much. And I will stop sharing the screen now, and yeah, we'll be open to questions.
Great, thanks Kanika, and a virtual round of applause to everybody involved. I think you've done a great job. You should be proud of what you've built. Any questions from anybody? Or Greg Abbey, would you like to say some words?
I'm open to questions from the wide group of audience we have here.
Yeah, and likewise, I want to just thank Greg and Ian and the students for really leading this, and it's really exciting to see what has come out. It's just, wow, it's so impressive. So thank you, and I'm looking forward to hearing others' questions as well. And if there's anything Greg or I can answer, we'll chime in.
Okay, so if anyone would like to ask some questions, just unmute and fire away or type in the chat.
Ian, I have a question on the chat.
Ooh.
You want me to read?
I can see one from Emily. Hi Emily, do you want to talk to us? You're muted.
Thank you, everybody. This is amazing. Really amazing. I'm wondering what the feedback interface looks like, so people, both users and storytellers, can contribute.
So Greg, do you want to answer that?
Sure. There is a contact on the website, which is ClimateTree.contact@gmail.com. If you have contact with Abby or I or Ian, you can also get to us that way. Our LinkedIn's are all on the team page, so you can also message us that way. And certainly we welcome collaborators with open arms, and contact us and we'll get you in the loop, and we can share documents and GitHub and everything else.
Thank you.
Okay,
Can I go next, Ian?
Yeah, go Chandra.
Yeah, I wanted to say that the work is really, really impressive, and especially since you did it across different campuses. I'm like, the thing, when Ian started his intro, I thought it was some professional website that he was showing as a prelude to the whole student talk. This is really, really good, and you should be really proud of it, all the people who worked on it. And it's a great presentation too, so congratulations, all of you. So I have I of course couldn't resist trying it out as the presentation was going on. There are a couple of things about the authentication and all that which don't seem to be working right now, but maybe small glitches which you need to look into. But I have a question about the 17,000 stories that you tagged with metadata. Did you do it manually? That's quite a task. Can somebody talk about this?
We actually, this is Greg talking. We had the students worked on this, and we also interfaced with Democracy Lab periodically at hackathons, and we got a person there to write an incredible scraping code, a web crawling code. And just in the same way that our research function launches you out with a place name and a theme, we are able to run the scraper, get hyperlinks, and then tag it according to the search terms by a place and solution type. So you can imagine, you can run that scraper for really any theme. It could be COVID-19. But then of course there needs to be a curator function, and that's the wiki spirit of this, which is why the students also built in the moderator role, so that we can kind of curate that content and clean it and make sure it's good.
Thanks.
We got a good question from someone about the blacklist idea. How would a decision to blacklist a user be ethically considered, keeping freedom of speech? Well, it's a geeky answer, which I'll give you. As you probably know, there's a lot of trolls out there. So assume, you know, someone decided to post a story about, I don't know, some naked romp in a villa with a football player. Then we'd probably blacklist them. But there's ways around, you know, around that. So just keeping trolls out is just a blunt instrument to do that. But the more ethical side, I'll leave to Greg and Abby to answer.
You know, it also leads to greater questions about what solutions are ethical and equitable in terms of climate change. Climate justice is a great interest of the climate change action community. And that, for example, would be a taxonomy to add so that people can search by those kinds of parameters as well. And yes, that could be a conversation that can go further than that, but I'll leave it there for now.
Good question from Abby. The level of great geographic search. How much work would it be to add the next level of population, such as small cities and towns like Olympia? What have we got in there, Greg?
So one of the filters with the geographic data is reliable data on a global level. And one of the issues of equity is actually that of data collection and processing and presentation. Something we're hearing in the news right now, like which countries can we trust with their numbers about COVID-19 and so on. So, you know, the United States, for example, does have population down to the smallest villages and whatnot. We have a somewhat reliable regular census every 10 years, but with also extrapolations between those years. But other nations might not have that, like South Sudan and so on. So some of the data that we're using is actually satellite models. That's where NASA comes into the picture. So you know, there's a few ways that we could approach that. One would be through the wiki function, where people actually from those places are able to upload their you know, their geographic data, such as population and so forth. So some things are definitely achievable for the United States. The question would be how to integrate that equitably across the globe. And data is getting better all the time. So with the scalability of the site, we also look forward to ingesting the latest and the greatest data.
Thanks, Greg.
Question from Pam. Curious to see how the different kind of people might use the tool. So how do people who've built the site, or Greg or Abby, see it living and taking flight in the world? What uses will people have of this?
I can give a shot on that one.
Now we've hit on the things that Greg and I can talk about forever. So, but we'd love to hear what Dan's saying, to hear from the students and their perspective on that.
Go ahead.
I have a quick idea on that one. I don't have a super solid answer, but my thinking in general is that it'd be great to see this as like a community that really comes together. And so I know a big part of it is the research tool, but I think the community is what will really make it succeed. And there's, like with any site like that, I think there's just room for evolution there. And I'm just curious to see what will happen, but that's what my hope is that it's really successful. And I think the key to that will be developing a strong community.
Also, there's the potential to make this, you know, the map functionality even more complicated with GeoServer doing geospatial analysis and stuff like that. It's kind of, there's a ton of applications when it comes to that.
Yeah, they're pretty exciting extensions that are possible. I personally, not a student, but I'd love to see if we can get some traction with local schools, find the climate clubs in schools locally. Again, it's all difficult in our virus times at the moment, but maybe there's a way we can connect with local teachers in high schools and see what they think and see if they can help guide us with the development of this site.
So for me, hi, this is Theodore. So for me, what I see from this website is that hopefully, for example, like the students from the local schools, especially the high school who are interested in the climate change and who are doing research about this, hopefully they can gain something out of it. And then also, like we would like to see, or at least it's for me, I would like to see that there is an interaction between the students or like other people who are involved in the climate change, and then like hopefully like people can also get closer together, and then like hopefully through the interaction, through the commenting on the stories or maybe likes or something like that, it can be fruitful, that the interaction and then like the teamworks, especially communications between like two users or like more than two users, can gain like new knowledge about the climate change, something like that.
Yeah, the ability to share knowledge across boundaries is powerful.
I'll pipe in real quick before the students keep going. This is Greg. As you can imagine, with the user microservice and the location microservice, there's additional layers that can evolve. For example, one thing we could web crawl for is climate organizations and catalog, have a global catalog of climate organizations, student groups. You know, you can imagine user groups where you have a class and there's the class's students register, and then that would really facilitate, oh, I want to talk to someone over in that village or in that town or state. And one could even imagine scraping government websites and government contacts. So, and that includes also universities from all of these geographies. So you can really imagine the scalability, the architecture that was built being able to accommodate a lot of that growth.
Question that just slid off the chat panel was about adding other layers of data, such as population of animals, birds, cow density, that stuff. Presumably that's just stuff, if we can acquire the data, we could add that to GeoServer and serve it?
Yep, exactly. Yeah, but it would have to be potentially an extension of our current data, or sometimes those layers are already made and they're just, there's shape files, or you just throw it in GeoServer pretty quickly. But to do any like spatial analysis on our end, we would have to do a lot more work looking at those files.
Yeah, sure. And a good question from Abby. How did the experience from the first week in March, we've not been able to meet physically on any campus. So how did all this impact you all? From my perspective, it made it easier because the audio was better than from the classroom in Boston, but I'm sure it had impacts on the way we worked.
I completely agree with that. Yeah, the audio is much better overall.
Well, but for me, it decreased my productivity, but at least, fortunately, I can get it done.
I don't think you're the only one who experiences decreased productivity.
Yeah.
Slacking from home, as my friends call it.
Exactly.
Okay, we're pretty much out of time. So any last questions, or did I miss any in the chat? If you've got a question, feel free to just unmute and fire away or type it in the chat.
I'll say one more thing, Ian, because I got a private question from someone who had to who had to leave, who works for the Environment Ministry of Canada, and they were wondering whether we could catalog these public investments by their dollar value. And of course, that could be possible too. That could be a tag. You know, we could have time and location currency translators as well. So, oh, that cost, you know, 20 million pounds in Great Britain in 2002. How much would it cost in the United States today? And that public financing aspect is definitely an important part, but also accommodating anyone who wants to, you know, the whole spectrum of people who want to share videos and inspiration to people who really want to get into the nitty gritty is certainly a challenge. And I think this demo demonstrates that we can do that.
Yeah, that sounds fascinating. Okay, thanks everyone. Thanks for participating, to the class and the audience for listening. We hope this site will go further. We'd like to seek some funding to give it a nice place to be reliably deployed. And we'd also love to find some money to invest more development and extension in it, and also get people to help us with the open source development. So if you know of any avenues for that, please talk to Greg or Abby or myself, and we'll see where we can take this thing. Thanks ever so much, and once again, congratulations to everyone in the class. You did a great job.